Shielded metal arc welding. Metal arc welding is the most common type of welding in joining process. About 50% of all industrial and maintenance welding is done by this method. An electric arc is struck between flex-coated consumable electrode and the workpiece. The electrodes are thin, long round rods that are held manually. The electrodes are in the form of a stick, therefore it is referred to as stick welding. Working principle. Shielded metal arc welding is carried out closely just as other arc welding processes. An AC or DC power supply, usually ranging from 50 to 300 ampere, transfers current to the electrode holder in order to produce an arc, leading to intense heat to melt the tip of the electrode and the joining portion of the workpiece with the arc. The arc length is maintained by the welder by holding a consistent space between the electrode and the weld pool that is formed on the workpiece. This workpiece bond as soon as the arc is taken off it, and then the joint is obtained. Working. In shielded metal arc welding, in order to strike the arc, the electrode is brought into contact with the workpiece by a very light touch of the electrode to the base metal and then pulled back slightly. This process initiates the electric arc and hence the melting of the workpiece and the consumable electrode. The heat generated melts a portion of the electrode tip, its coating and the base metal in immediate arc area. This causes droplets of electrode to be passed from the electrode to the weld pool. The molten metal consists of a mixture of base metal, electrode metal and substances from the coating on the electrode. As this cools, this mixture becomes the weld. The electrode coating deoxidizes welded area and provides a shielding gas which protects the weld pool from atmospheric contamination. A bare section at the end of the electrode is clamped to one terminal of the power source, while the other terminal is connected to the workpiece being welded. The tip of the electrode should be at lower angle to workpiece, which allows the weld pool to flow out of the arc and slag floats to surface. To finish up the weld, the slag should be chipped away using chipping hammer and a wire brush. However, mechanical mills can be used. As the welding progresses, the electrode melts. The welder must periodically stop welding to remove the remaining electrode stub and insert a new electrode into the electrode holder. This process is best suited for workpiece having a thickness of 3 to 19 mm, although this range can be easily extended by skilled operators using multiple pass techniques. The multiple pass approach requires a slag to be removed after each weld bead. If the slags are not removed completely, this can cause severe corrosion of the weld area and thus leading to failure of weld. It prevents fusion of weld layers, compromising weld strength. The slag can be removed by wire brushing or by chipping of the weld. For sheath metal welding, DC power supply is preferred because of the steady arc it produces. The power requirements are generally less than 10 kilowatts for shielded metal arc welding. The equipment consists of a power supply, cables and an electrode holder. The diagram on the left side shows the working of shielded metal arc welding. From the power supply, electric current flows through the metal electrode or stick, and an arc is formed between end of this electrode and the workpiece. The arc melts both the metal rod and the pieces to be joined. The metal from electrode is injected into a molten weld pool and mixes with workpiece as the electrode is heated by the arc. Some of the covering on the electrode releases protective gases that shield the weld and help stabilize the arc. The remaining covering melts and covers the molten weld pool with a protective slag layer. This slag layer protects and helps shape weld as it solidifies, but it should be removed when the weld is cooled. Advantages: shielded metal arc welding is versatile, that is, it can be used for welding of various metals. The equipment used is cheap and simple, and this method is suitable for outdoor applications as well. Disadvantages: this process is discontinuous as the electrode needed to get replaced each time. Fumes produced makes this welding process control difficult. With the shielded metal arc welding, the weld may contain slag inclusions. Labor costs and material costs both are high. Applications: they are used in the maintenance and repair industry. They are also used for the construction of steel structure, shipbuilding, pipelines, and in industrial fabrication. They are used to weld iron, steel, aluminum, nickel, and copper alloys. They are useful for work in remote areas where a portable fuel power generator can be used as the power supply. Thank you.